Okay, and we're live. Shall we just wait for Spencer to get back before we get started?
Yeah.
Okay. Hey, everybody, we're just going to start in just a moment. Thank you for joining us and welcome.
When I press reload on the YouTube channel, it's not showing me the live.
Yeah, it might take a moment for it to actually show. So, how's it looking now? Yeah.
I see
I see people.
AES live stream.
I see people tuning in, so or on the chat at least.
All right.
Do we sound okay out there? Let us know in the chat, please. Great.
Sounds good. Yeah. They're saying it
Great.
sounds good. All right. Should we start?
Yeah, let's get started.
All right. Hi everyone, and welcome to the Audio Programmer Meetup. Thank you so much for tuning in and joining us tonight. My name is Timur. I'm really excited to be here. We have again 3 amazing speakers for you tonight. Before I get to that, just a quick personal note. You might have noticed that I wasn't actually here last month. That was because I was unwell. I was actually completely off the grid for 6 weeks. So if anyone follows me on Twitter, you might have noticed that there wasn't much going on there. But the good news is now I've recovered. I'm back. I feel good. So I just wanted to give my co-host Josh a big thank you for running last month's meetup on his own, doing all the moderation, all the tech on his own. So thank you very much, Josh. So I'm happy to be back, and you're ready to get started. So I'm just gonna head over to Josh. Do you want to introduce?
Yes, great. So thank you everybody for coming, and once again, thank you to our 3 speakers, Gabriele, Spencer, and Scott, for joining us. And I'd also like to give a big shout out to our sponsors. So we have a new sponsor this month, who is Juice, which of course most of you know of. And so I'd like to give a special thanks to Juice for supporting this monthly meetup. And I'd also like to give a thanks to our other sponsors, Focusrite and Sonux, for also supporting the meetup. Another quick announcement that I'd like to make is that we will soon on the Audio Programmer channel be offering Soul tutorials. So we will have a Soul tutorial stream, and I know that's going to make Jules and Cesare very happy, who are the creators of Soul. And so that is going to be given not by myself, but by another person by the name of Daniel Strubig. And he is out in Copenhagen by way of Germany, and he's excellent. And I know that you're going to enjoy it, and those will be coming very soon. So the final thing that I would like to say, and I'm going to speak a little bit off the cuff here, so excuse me if I have to pause for a moment, but the final thing that I'd like to say is just that, of course, with recent events, with Black Lives Matter and the protesting that's happening in the States, I've felt an obligation as the founder of this community to say a few words, and that the foundation of the Audio Programmer is built on being welcome to people of all different types of backgrounds and all different walks of life, and that as a person that has watched many documentaries on the Holocaust and on some of the terrible things that have happened in this world, one thing that I've thought of a lot is if we were faced with a choice of doing the right thing, if we would have the if I would actually have the power to stand up and be able to stand up for what I believed was right, and in that, I pledge as the founder of this community to try to do what I can to make that pledge and to step up when the time comes. And so we at the Audio Programmer support the Black Lives Matter movement, and we support any movement that is about equality. And I feel that we have an obligation as people within the industry and for people that may be coming in the industry, that if the choice comes to do the right thing and to fight for equality and to fight for for people's rights, that I hope that we can do more as a community to ensure that that people of all backgrounds are able to feel welcome to come into our space and talk about the world of audio programming. So the last thing that I'll say about that is that, of course, many of the things that we talk about here in these meetups are technical, but one thing that is not often talked about is our ability to work with other people and being able to work with people of other backgrounds that may have different beliefs than us, and that this is just as important of an aspect in audio programming as the technical aspect. If not, it's more important than the technical aspect. And so I call upon the audio programming community to pull together to help make this world a little bit of a better place, even if it's in our niche of audio programming. So that's all I have to say about that. And let's go ahead and kick off the meetup.
Yeah, thanks, Josh, for these words. I couldn't agree more with everything you just said.
Thank you.
So let's start the meetup. Our first speaker is Gabriele Bunkheila, and he is a senior product manager at Mathworks, where he coordinates the strategy of MATLAB toolboxes for audio and DSP. And that's actually really exciting because I just realized that everywhere I worked in my career in the music tech industry, people would use MATLAB as like the standard tool for DSP. But I've never actually met anyone before who worked on this software. So really nice to meet you here tonight, and really looking forward to your talk, creating audio plugins with MATLAB.
Yes, and I'm going to be streaming this video from my desktop. So if there's anything that wrong with the sound, please let me know so I can fix it right away.
And if you have questions, then feel free to ask them in the YouTube chat, and then Gabriele can answer them live here after the talk.
Great. And here's Gabriele.
Hello, thank you for tuning in. It's a pleasure to be here, albeit virtually. So my thanks also go to Josh and the Audio Programmer for the invitation. My name is Gabriele Bunkheila. I work with Mathworks, the makers of MATLAB and Simulink, where I work in product management for our products for signal audio processing. A few words about this content. The title is Creating Audio Plugins with MATLAB. This is not yet another talk to introduce you to new software tools to create commercially viable audio plugins. This is more specific. This is a workflow designed for people who are familiar with digital audio processing and hence very often also with MATLAB to take their algorithmic, their math, their ideas and translate them into an audio plugin, which is a tool to verify and validate, test that the algorithms they put together is sound from an aesthetic or functional perspective. Okay, it's important for me to let you know that this whole workflow has been, so to speak, honored or celebrated for the third time this year in a competition that we, Mathworks, have been organizing with AES, the Audio Engineering Society. It's called MATLAB Plugin AES Student Competition. This is the webpage. I'll show you where to get these slides later on, so you'll be immediately able to access these hyperlinks. So the competition is open to students. If you're a student, I highly encourage to go there and have a read. I'll mention more of this competition later on. Right, before we get started, I thought about making a version that's a bit more live than the traditional agenda. I'll show you a video. It's going to be a bit dense, but it's going to go in just over 2 minutes over the main topics that I'll cover during this session. I'll hit play, I'll let you watch. Don't expect you need to understand everything, but try to follow, and then we'll go more slowly into these steps. Okay, I'll make no assumption that you've been able to grasp every detail of this video, but hopefully something stuck and you'll be able to follow more easily what follows. So let me start by discussing the agenda in a more traditional way. So we'll start with a short introduction to MATLAB with a simple audio processing task such as the one that you've just seen. We'll discuss how to take that MATLAB code that is generic and refactor in a way that is ready to create and generate an audio plugin, always using MATLAB code. We'll discuss how to turn that MATLAB code into an actual VST plugin, and a few words in terms of the basics of how to be able to take that VST plugin and use it within a DAW, a digital audio workstation. So this won't be covering a lot of things. We won't have a ton of time. 40 minutes just fly, and we've already used a few. So let me get started and jump directly to MATLAB. Okay, I'll start by showing you something quite specific, which is a MATLAB live script. This is not something that has existed for the whole MATLAB history. It's something similar to, say a notebook in Python. It's a mix of code, you can see here and here with a great background, and a numbered line of text to comment and describe what's in the code, and to separate the code into sections that can be executed independently. And then there will be some of the visual output created by the code. Okay, so this is an easier way to remember what you've done and to share it with others. Let me show you what I have here. At line 1 and 2, I'm defining a file name, which is a file that I have here in my working folder where I'm now. And based on that file name, I'm opening the content and I'm importing the data in that file. So it's an audio file, it's an MP3 file. So as an output, I'll get the audio samples and the sample rate. Let's execute this and see that as I do that, I've created a few variables here in my MATLAB workspace. Let's take a look at what these are. The simplest one is the sample rate, okay, 44.1 kilohertz, and that was the metadata in my audio file. And then I have the actual audio samples. Okay, there's a long number here. The important aspect here is to understand that this is an n, a long number, by 2. It's an array. It's a matrix composed of 2 columns. Each column holds the samples of a channel. Okay, first column is the left, second column is the right channel. Okay, I can take that data and plot it as I'm doing here. Before plotting it, I'm doing something else. I'm creating a time vector associated to my data. So I can do that based on the sample rate. I create a sampling period here by doing 1/fs, and I'm multiplying that sampling period by a number of subsequent integers going from 0 to the length of my sample. So the length is the largest dimension of the matrix here. So this large number n, let's call it, and subtracting 1 because I'm going to 0 to n minus 1. Okay, so sample period by the integers from 0 to n minus 1 gives me the exact time instance associated with my sample. So I can then plot t data, so the time against my samples, and get this plot down here. Okay, this plot down here will display all the values of my sample. You'll see the name was Funky Drum, so you see all these percussive events. We'll see more in detail in a minute. It goes from time 0 to about just under 25 seconds, so quite long to listen. So I'm sparing you that just for now. You can zoom in and see that, yeah, I do have, say, here, I do have two channels here, left and right. I can see the right channel on top of the left channel. As I do modifications on my plot, I've got some code that I can use to update it, my existing code, if I want, just by clicking a button. But let me move on here and show you what I have in the following. Okay, so now in the following, I'm narrowing my attention to only the first 3 seconds of those signals, because that will make it easier to iterate, do something with that data, and listen to it more quickly. So how do I do that? I'm showing you the 3 typical ways of indexing, as we call it, or referring to a content of the whole data that we have. For the time, I'm defining a new time of only 3 seconds by saying that I'm interested in only that portion of this time vector where its own values are less than 3 seconds. This is called logical indexing. This operation inside here creates a vector of logical values, true or false, 0 or 1, and only where this condition is satisfied, I will have 1. And the output t only gets those values at this time where the condition inside the brackets equals true or 1. Okay, so this will be a shorter time vector than the one that we had created earlier. And then here I'm using a more classical way to index into my original array of samples. I'm selecting separately the rows that I want and the columns that I want. And in the middle, there's a comma. So to the left of the comma, there's the rows that I want. Here are all the rows from 1 to the length of this vector that I've just created. Okay, these are, again, the sequence of integers that I create using this colon operator. This is a pretty popular MATLAB operator. Okay, remember that MATLAB has 1-based indexing, so 1 will be the first row in this case of this array data. And then here for the columns, I'm using this column operator in a slightly different fashion. Okay, just column means all the columns in this matrix. So all the dimension numbers in here. I could have written 1 column 2, and this will have been all the integers between 1 and 2, so 1 and 2. But just putting down column and shows me that I'm considering all of the dimensions in this dimensions here. Okay, and then I'm just doing the same thing as before. So I'm plotting x, and this is some prettification of the plot. Let me execute this. And after that, we'll see that we have something like what we had before, with some, some axis legends, time in seconds, and sample values, customized legend, left and right channel, something easier to understand when you share it with somebody. Okay, so this gives me some insight. I could optionally, if I wanted to, also easily listen to these samples by using a command like sound, for example, x and the sample rate in this case. By saying sound sc, sound scaled, I'm also taking my audio vector and normalizing so its minimum and maximum are between 1 and 1. So I ensure that I don't clip or I don't have a dynamic range that's too low. Let's listen to that together. It's 3 seconds. Okay, so this is a stereo signal. We played both left and right channels. If we went back to our workspace, we would realize that all the things that we've done were reflected here. For example, X is now an array with the same number of columns, 2 as my original data, but a lot fewer sample. In this case, just over 130,000 samples, okay, by 2. And my vector T has the same number of values as my new array. Okay, now it's where here in this script I do something with that audio data. So what do I do with it? Again, the column operator here. I'm creating a new array left made of all the rows, remember the column operator, and this time only the first column of my 3-second array of samples X, and doing the same for the second column. So I'm creating 2 separate arrays, left and right. And let me execute this. What do I do with them? Left and right are here. Right now, I take the mid channel as the average of left and right. Note that I only need to say plus and minus here for the side, and that operation, as well as this normalization, will apply to all the samples in left and right and their sum. Okay, same thing for the side. Instead of summing, doing the average, I do half of the difference. Okay, that's a conventional way to define psi. Okay, so let me do that. And mid and side are here, same dimensions. And now I do something which is slightly new. I take my side and I multiply it by a gain greater than 1. By doing that, I create a new vector side that I use to invert this operation and go back to a left and right channel, summing the mid to the new side and taking away the new side from the mid. I have 2 new channels, left new and right new, that I then combine together or concatenate together using this also very popular MATLAB operator. It's based on the square brackets. It's called the concatenation operator. Okay, you put an array here and an array here, separating this case by a comma. The concatenation operator will form a new array by concatenating those 2 arrays horizontally. I can do that because both left new and right new have the same number of rows as here. So by executing here, I obtain a new array X new that's got the same dimension data types as my initial 3 seconds array X, but it will be different. And what I do here is that I use again the concatenation operator, this time though with a semicolon in the middle. What does this do? Instead of concatenating horizontally as with the comma, this concatenates them vertically, which is also possible here because X and X new have the same number of columns. So they can indeed be concatenated vertically. And by doing it, I have first the original stereo signal and then the expanded stereo signal. Why expanded? Well, because it had an amplified side as specified it out here. Okay. By doing that and by giving the result to the sound scale command, I will listen first to the first 3 seconds and then to the second 3 seconds. So let's do that. Right, so hopefully really I'm hopeful about that. The sound is getting to you in stereo mode. You're able to listen in stereo mode. You will have appreciated that the second version was expanded in a stereo, in a perceptual meaning. Okay, right, so now we've got all these commands. We've done something interesting. The interesting bits that we've done are from here around, from line 15, where we create the mid and side, and then possibly here to 20. And these things are fine. They are within this script, but it's useful sometimes to encapsulate all those commands together. And a useful way to do that is to create what we call a function, which is what I have here. Okay, let's put it here to the side. A function is a useful way, as I was saying, to encapsulate command and to make them callable more easily from another program. So what we have here is exactly what we had in our reference code to the left down here. I'll let you appreciate that line by line, although here I have a more compact syntax because I don't create the intermediate variables left and right. I'm taking really left at the first column of X and right the second column, doing the average. Same thing for the side with a minus sign. I'm multiplying the side by this gain. Okay, in this case I had a hard-coded number. In this case, gain is a variable, and this variable is given to me through what we call the function interface. Okay, you can see that in this case, we started our code with this keyword function to say that this file for us encapsulates a function. And a function can be called with this name by passing in these two variables, in this case, the array of audio stereo audio samples, a scalar gain, and it will return the results here, which is the recombined expanded stereo sample formed of mid plus side on the left channel and mid minus side on the right channel. Okay, so what makes this different from the code that we had here is that now we can call all these commands using just this syntax. So if you look at what I have here at the left hand side here, I've got a bit of code that calls my function by saying stereo width, passing it X, passing it a variable gain that I define here. In this case, I've got 1. And then in this case, I'm also plotting it. So by having one line of code, I'm calling all these different lines of code, and I can easily pass different values of these parameters and see what happens. In this case, for example, if I play this with a value of 1, I have the original signal and the original plot. Let's do it once. Okay, I'm sure most of you will be familiar with this plot down below here. This is the right channel against the left channel. So for mono signals, this will be a straight line, diagonal line, because the two are the same. So the various samples left and right will be distributed all over the diagonal. Let's try it. Okay, straight line. And if I give this a value greater than 1, you will see that those 2 points will be more spread out away from the diagonal here. Okay, as well as sound, obviously more spatialized. The sound for us was down here. In this case, always part of the same cell. Okay, so I think I would say this is quite useful. This is a situation where we have our code encapsulated in some way, and then we have a way to change the parameters interactively. In this case, these sliders are made available by the live script, but you could think about simply changing this value by hand and experimenting what's going on. Okay. So now what makes this way of organizing code, which is already encapsulated, which gives us a way to change parameters, possibly also interactive, makes it different from what I would see if I had this algorithm, so the stereo expansion algorithm, expressed as a plugin. Okay, in this case, executing in Reaper, as you've seen in the video. Let's try it. Original. Progressively taken to mono, and then expanded, right, up to a maximum value of 4. So the question is, what makes this different from this? I'll answer this question myself to make things quicker. So this gives us a way to change parameters as the audio flow through the algorithm, and we can interact with the algorithm as the audio flows, and the algorithm is processing the audio, the input audio, one block or frame at a time, okay? Which was not the case in our MATLAB function down here. What also makes this different is that the way we define the algorithm in this plugin is standard. It abides by some rules, so when we load it into a hosting environment, like in this case Reaper, it will understand what goes on. In this particular case, obviously this is a BST algorithm, so this is abiding by a very strict set of rules. But more in general, if you want to express an algorithm in a way which makes it easily usable and tunable by a user, we need to force us to write code in a more organized way. So let me go back to my code. One first thing that I feel like pointing out is that in this case, I have 2 inputs, and I need to understand what those are, in what order I need to pass them. If I pass the first the gain as a first input and the audio as the second, obviously the code in here would not understand. Also, any user would know at least how I'm called, and then I would have to structure my code to be able to process, to accept one block of samples at a time. For this simple algorithm, the code that I have here that's able to process a whole vector of recording is no different from the code that would process one block of samples at a time. But things may be different with algorithms with state. It's worth pointing out. I won't have time today to give you an example. Okay, let me show you an alternative version of this that I have over here that I call stereo with expander. So I give it the name of a thing instead of an action. That's pretty common with these different ways of doing things. Let's start from here. In here, we've got exactly the same 4 key lines of code or commands that I had on the right-hand side. I said exactly, but it's not exactly to the point, and I'll show you why in a second. The other difference here, I mean, this is still a function, but it's called process. It's not called stereo with. Okay, it's got a name that's standard. And also this function is in a context that's wider than it. Okay, it's in a file that starts with a keyword that says class def, and indeed this is a class definition, or sometimes this may also be called an object, as is an instance of a class in MATLAB. Not all MATLAB users are familiar with classes and objects and with object-oriented programming, but the lucky side is that this is simpler to do in MATLAB than it is in other languages like C++ or Java. Okay, so it's worth taking the leap and understanding the few things that are useful here, because classes can help us encapsulate and organize code in a way that makes things a lot more clear for users and hosting environments. So what's one other difference here? This, instead of having the gain here, the gain was not a hard-coded number. It was a variable passed in through the functional interface. In this case, width is something slightly more advanced in this case. This, you can see that it's expressed as plugin.width. Plugin is the first input here, is a way to pass in our own object. It's the equivalent of the this in C++. And this gives us a way to access a value that's available in here as a class property. So a class is a way to group together code, routine, functions as the one in here, with data as the one in here, for example. This data was a properties or was a parameter that I was changing. But properties or data could be something else in these types of classes. It could be, for example, values that I compute only once and I cache in a property value. It could be states that I cache in property values. In this case, this property is public because I don't say anything here. In other cases, you could have private properties. This is public because this needs to be seen by the user. So the user sees this, it sets a value, and when I execute the code, this is the way to access that value from the inside and use it. Also very important about this function is that it's got a standard signature. It always needs to be written this way. The first argument will be the object, the second will be the input audio, and the output needs to be the output audio. For me, programmer, I need to be aware of that and always write the signature in that way and use the variables in that way. For a user, somebody who takes this code from the outside, they will be able to know that if this is a MATLAB audio plugin as indicated here, it will always head a process method. So when they need to process input, they can call that. They can do that if there's a user or if it's an automated way to consume this code. Okay. So I was telling you about audio plugin. Audio plugin is a standard way to define audio plugins in MATLAB. All you need to do, and besides doing the right things over here, is that when you create a class definition that for you needs to be an audio plugin, you put the less than sign followed by this audio plugin with capital P. If you're familiar with object-oriented programming, well, this is saying that this concrete class is inheriting from the audio plugin abstract class. If you're not, just ignore what I've just said. Okay, so this way of writing plugins is already useful to use that in the way you're familiar within MATLAB. So if I put this quickly to one side here, and I show you another script that I've got here, this shows you a way to just call an algorithm on stream audio and tune it interactively from within MATLAB. Let me show you quickly. This is a simple MATLAB script, a more traditional way to organize code. It doesn't encapsulate the output. It doesn't give you the ability to format the text. You have comments here. And let me execute this cell of this script, this section. Okay, here I've got a spectrum analyzer. You've seen left and right channel overlapped because this is the first channel of the input and the first channel of the output. And when I have one there, this doesn't change. When I go to 0, these are separated. You're listening to all these audio drops just because the video capture is putting my old lap loop to strain. This has no reason to drop a priori. This is just a way to change this parameter interactively and see the results down here. Okay. So let's take a look at a bit more closely at this code. This is a simple while loop. And this encapsulates the idea of taking live input from possibly, in this case, a file visible up here. Okay, audio file reader, same file that we were using before, and doing it a few samples at a time. Samples per frame here, 512. It could be smaller. It could be larger. So this is a 512 by 2 array that I pass to the process method of my expander that I define out here earlier in the loop. Okay, and the input I write it to an audio device writer, which is a way to wrap a sound card as this is it, the outright, which is it was a way to wrap the sound card outputs. Okay, and so and while I pass the input audio to the audio expander object here and I press to get the output, I also have an opportunity to pass the object to this function parameter tuner that takes the code in here, understands that there's one parameter to tune and paints the parameter as I want it displayed to let me tune it. because the object was created outside, I could pass it to this function before I enter the function. And while I execute, well, before I enter the loop, and while I execute this loop, this function has access to the object. So when I tune it through the interface, that value can be propagated to the object because this is the same as that is executed out here. And so when it enters here, it will execute. You can see that also if I execute this again and change value, I can go down here, put a breakpoint here and stop, verify that the input that I have here is 512 by 2, and then the value that I have here is exactly the one that I tuned and reached through the interface, which is 2.61. Okay. So why have I shown you this? To say that this is enough to express code in a way that is standardized and ready to be tuned from the outside. Actually, it's almost enough, because if you go back to, for example, Reaper or even the interface in MATLAB, there's something specific about the way this parameter was tuned. It had a minimum that was 0, it had a maximum that was 4, and it was going from 0 to 4 in a slightly specific way, because here in the middle the value was 1. Okay, so this was not linear. This is not 0, 1, 2, 3, 4 as we'd expect. So there's a specific way to scale values from here to here. So there's some additional metadata that I need to specify, and was already specified here, although I hadn't shown it to you. This is a bit of ugly code. So this is the type of code that you copy paste, but this helps whoever consumes this code in an automated way know what you want to do with that width parameter. And this says that you actually want to take that width parameter and you want to create a control for that, a control with a minimum of 0, a maximum of 4, and with a mapping from min to max done as a power of 2 in this case. But that could be log, could be linear, etc. Okay. If you specify all of this, you're not only ready to automate painting user interfaces using MATLAB like this, and you're ready to process audio in a stream fashion, you're also ready to generate plugins from this. And this is what I'm doing here. If I take the name of my class that I was also using here to create an instance of it, and I use it through this command, generate audio plugin, let me execute this section. You take this MATLAB code, you convert it to C++ under the hood, you join the algorithmic code right here with a right plugin interface. In this case, we're using Juice under the hood. Well, then the output of this will be a BST plugin, because what we're doing here, again, it's generating code, putting it together with plugin interface, generating a Juice project under the hood, and then compiling also this Juice project for you. Okay. So all of that things in this case will happen and will work. And what we've done, this generator plugin is made available with a toolbox called Audio Toolbox. What we've done is to package this whole thing together to make this transition as seamless as possible. And the idea here, again, is to enable people who write code to do signal processing to do this transition as quickly as possible. Always, there's always the few caveats, right? So we are taking this code and translating it to C++. In this case, this is possible, but it's reasonably easy to think about examples of writing MATLAB code that are not easily translatable to C or C++. So this is to keep in mind. Or the way to write MATLAB code so that it's supported to generate C or C++ is documented. So when you write code that it's intended to generate a plugin, think about that. Go and read the documentation, see what's allowed and what is not. Okay. Other things. There's when you do this, you generate, I was saying, C++ under the hood, and you only need Audio Toolbox. The ability to convert MATLAB code to C and C++ has been around for a while, and it's best known to people as enabled through a product, an add-on product that's called MATLAB Coder. And that product is used to take MATLAB code and give you source C or C++, then you can go away and do whatever you want with, okay? In this case, we're not doing that. We're giving you the binary. So all you need is really Audio Toolbox. Don't think that you need MATLAB Coder, although if you go to the online documentation for MATLAB Coder, which is accessible, that will tell you what's allowed and what is not, all right? If you have a license of MATLAB Coder, what you could do here is to add a flag in this command, a flag that says -juice project, and that will give you a zip file that you can open in ProJuicer and give you the whole ready-to-build project that you could go in and modify it. For example, to change the type of output plugin, to change the user interface yourself, and to take the project further. Okay, so that's another option that I don't have the time to discuss today. Another thing to keep in mind is that even if you write good MATLAB code that doesn't give you errors in MATLAB that translates to C++, you could always think about doing something stupid if you're clever that could possibly blue screen your plugin, and hence also your plugin host, your DAW, and your system. Okay, so we could have thought, okay, we should definitely push people to write the unit tests, do things properly. We know that a lot of MATLAB users are spoiled because doing something that, a mistake in MATLAB, throwing an error is not that bad. Okay, you get a red message and a chime, but so not many people like you, not many MATLAB users are used to regular software development, unit testing, and those rigorous approaches. So we created an additional command here that you can see here. I won't execute it for short. It's called validate audio plugin. Before executing generate audio plugin, we encourage people to run this. That would take your MATLAB code and test it in a few different situations with frame sizes of different length. And then it will generate code and do the same tests. And so it will ensure that your code is robust enough so that we're reasonably confident to tell you, okay, you're good to go and generate your plugin. Your code is very unlikely to crash. Okay. All right, while I was talking you through all these different aspects, this has finished executing because this line has been reached and I can see the output here in my command window. That means that I've produced here in my current folder a DLL because I'm running in Windows. Under Mac, you would have a DOS.bst. Now, this is your BST plugin, which is ready to go. In order to use it within a host environment, you need to go to your effects button here. In this case, we have it loaded, but we can remove it. And first of all, you need to go to your options and make sure that the plugin lives in a folder that is within, in this case, your VST path. Your VST path is available here in Reaper, for example, but any hosting environment's got its path. And here I have a number of folders included here in my path. One of my folders here is this C MATLAB VST plugins, where I can optionally directly generate my plugin if I provide an out directory flag here with the right folder. So instead of generating a plugin in this folder as I was doing, I can directly generate it into a target folder that is already within the VST path of my host. So then I can go to add, possibly refresh this list and find my my generated plugin here in this case. Okay, and here it is, and this is just what we saw before. Running natively, C++. Okay. Now, one of the things that I haven't told you about in this session includes customizing the plugin interface. So I just wanted to give you an idea of the kind of things that are possible these days. There are ways to, instead of having the default horizontal slider, you can position that slider vertically. You can lay out your different controls over the canvas. You can have different types of controls, such as knobs, switches, and other sort of things. Okay, this is probably not enough to, as I said at the beginning, to give you the ability to develop professionally and commercially valuable plugins. But it gives you the ability to structure your interface so that a user can interact with it in a meaningful way without too many assistants. All right, I think this is quite enough in terms of what I wanted to show you. So let me quickly go back to my slides and try to point you through a few other resources. So that's where I wanted to go. Right, so there are many things that I haven't told you about. I'd like to list them, at least the most important that came to mind, so you can know where to go to take a look at a few of these topics yourself. So first of all, I haven't go into details on how to create a plugin with states. The example that we've gone through was stateless, so it was because it was simple, but additional attention, additional care is necessary when you plug in and your algorithm has states. Now, there are a number of things that are built into MATLAB these days, specifically into Audio Toolbox. You know, fundamental audio processing algorithms like equalizers, parametric graphic, dynamic range processing algorithm, fast convolution, you name it. So I haven't gone through any of these. You're more than welcome to go and explore this before reinventing things from scratch, because they will also generate code. So if you use them in your plugin, you'll be able to generate also a BST plugin from them. I haven't tell you anything about how to profile code, although that's important. I won't hide under behind a finger and say, you know, MATLAB is efficient out of the box. MATLAB can be actually very efficient for audio processing and real-time prototyping, but it can also be slow. And that slowness, that bad practices in programming, can propagate to the generated C++. So it's useful to profile your code starting from MATLAB to understand where the bottlenecks are. And there's a few things to say which I haven't today. I haven't told you in detail how to code in MATLAB for generating C++. I've just told you that it's good to pay attention to it, because not any MATLAB code can generate C++. I haven't told you anything about how to configure MATLAB to access a compiler and use it. It's straightforward, but it's important that you remember that you need to do it. Check what other compilers supported to generate plugins, and install it and configure MATLAB to use it. I haven't told you anything about how to verify that the plugin that you generate is numerically equivalent to your MATLAB code. And a good way to do it is to use MATLAB as a plugin host when you host plugins in MATLAB. And that's not just limited to the plugins that you generate, but applies to any plugin available there that these days you can use in MATLAB. That plugin becomes an object in MATLAB. So you can tune it using a programmatic approach by saying plugin object dot property equals value. And that can help you also quite easily ensure and validate that the plugin that you generated is numerically equivalent to your reference MATLAB code. I showed you that you can customize your plugin UI using a few useful ways. You can also customize the appearance of your controls. So all of that is documented, but I haven't shown it to you. And I also haven't in detail show you how it works to export your project to choose and to open it up. Okay, and there will be a lot more things that I haven't shown about. So, but you don't need to rely entirely on what you heard today. Associated with that competition that I talked about at the very beginning, there's also a resource pages on mathworks.com. The link is below. On this page, you'll find also a button to get a free license to use MATLAB to take part in this competition, which will have all the add-on products to enable you to get started quickly. It will also have a list of technical resources, okay? Start of things here, specific links to documentation for really relevant things that are useful to authoring plugins. If I call out the first things that I suggest you to look at. One is this 4-page paper submitted at the AAS conventions a few years ago, when this workflow for generating audio BST plugins from MATLAB first became available. And then there's this 1 hour and a half online video that goes through the same things that we went through together today, along with a few more of the things that I haven't mentioned that are listed on the page before. And there's more here, okay, including a link to a gallery in the MATLAB documentation with pre-built examples of plugins that you can use and generate BST plugins from right away. They're ready to go, but you can also go inside, understand how they're made, slightly modify things to start writing your plugin, not from scratch, from existing example, okay? Another useful place to go is the submissions to the previous years. Here I'm listing just the ones from last year. You can see that the first place, you see the submission by Kristen Steinmetz, who I know came to this meetup probably a couple of sessions ago. All of these submissions have video code, Christian has as well, to go with it, a wonderful website. And if you use the tag here below to look in MATLAB Central, which is the code sharing website for MATLAB code, you will be able to go also to the submissions from previous competitions as well as the tutorial code. Okay, now this is the link that I made available. It's going to be available for about 4 weeks, where to download these slides as well as all the code that you've seen today. Okay, you can take a snapshot of this and then very patiently find it again. We'll try to put it in the chat window when I stop, so you'll have a way to get here and access the code and the slides. I also suggest that if you're a student and if you intend to take part on the competition, so you're most than welcome to email me about this session if you have questions, but especially send me an email so I can put your name down and your email address to a mailing list for announcements. We'll use that list to announce further tutorial, but also to give updates about the dates for this competition. In this COVID situation, we're trying to stick to plans. The deadlines for submission were supposed to be around mid-August, and to be able to organize the showcase and awards on time for the AES convention in New York in October. But things are getting very weird. Obviously, this year, we're not sure that we'll stick to plan exactly. And so please do subscribe to an announcement. That will be very useful, because we'll try to make things clear as soon as we know about them. Okay, and with that, I'll try to wrap things up and stop and open up for questions. Thank you.
Yeah, hi. Yeah, Gabriele, thank you so much for this talk. We have actually quite a few questions.
Hey, great.
So let's start with, so quite a few people are wondering about the code that is being generated under the hood. So Joseph asks whether we actually have access to the source code of the compiled plugins that's being generated. And then Jose asks how readable that code is, if we do have access to it.
Yeah, let's talk about that. So the process that takes MATLAB code and generates C++ has been existing for a while. And I guess the difference between seeing it or not is just a licensing thing. So we try to make this workflow available without asking people to pay the premium for having C source from code generating from MATLAB. So you just need to have MATLAB Toolbox, which is a normal toolbox, obviously not for free. But it's a relatively modest cost, especially if you're a student. So if you have that, you get the binary. If you want the source, then you need just to add a license for another product on the machine where you generate it. It's called MATLAB Coder, and that can give you either just the source code from the MATLAB code, so the source C++, or if you use that workflow generator plugin with the right flag, it will give you a ready-to-build juice project. You can open in ProJuicer, and obviously everything will be open there. In terms of readability, so the code is designed to be readable. Anything that is generated by a machine will be sometimes less readable, well, often less readable than the one authored by an experienced and good programmer. Now, it was quite easy for us to make very readable the juice code, the code that's all around the plugin interface. That should be really the same as you used to write it if you are. And then there's the algorithmic code. So it will go in different places in different files. The algorithmic code, it's the code that you put together, and then there's the source code for all the algorithm that you use. There was a question about, for example, using LU factorization or many other things. Yeah, the vast majority of those things, unless there's a limitation in the doc, is supported. And so, but when you get the code for the LU factorization, that's not probably code that you want to go in and modify. First of all, it might not be all that readable. It's you should definitely be able to make sense of it. It will not be pretty. And then you always discourage to go in and edit that code, because that really breaks that magic in between the MATLAB code that it's easy to interpret and then the C code that's supposed to be implementation.
Right. Thanks. Yeah, we have another question. Quite a few questions about performance. That seems to be the other kind of main concern. So Architect asks, how performant are the resulting plugins? And they also mentioned that Unity actually has some problems with generated code. And then Josep says that they have implemented quite complex stuff with MATLAB, including vocoders and denoising, spectral re-enveloping, stuff like that. and how efficient would be stuff like that in real time?
Right. So in general, so this workflow is thought to not to generate professional things, but it should be reasonably performing. So the first thing is that the code that gets generated really depends on how you write your MATLAB code, and writing people is often surprised when I say, I've been using MATLAB for 20 years and I've been with Mathworks for 12. So I know how to speed up MATLAB code. I used to be an application engineer, so supporting customers. I used to get code and a couple of tweaks speed it up by a factor of 300. That's not always possible in other languages, because in MATLAB, you can do stupid things. It does let you do it. You don't have to. There's a ton of documentation on writing MATLAB code in a way that's efficient. It depends on how you structure it, how you partition it. It depends on how you use indexing. It depends on how you vectorize. It depends on a ton of things. Using the right functionality, for example, to do FRR filtering, to do convolution. You can do convolution probably in 100 different ways, and some of those can be very bad. So provided that you use the right bits and pieces, building blocks, and your programming practices are good, then your generated C++ is a good mirroring of that code. So that too should be very good. There's a caveat though. When you generate C++ in MATLAB for other workflows, it's quite easy to plug in optimized libraries. For example, you want to use FFTWs when you run an FFT. You want to use a specific library optimized for Intel multi-threading where you use a convolution. For when you generate plugin, things are pretty simplified, so it doesn't allow you to optimize things to the bone, but it should be reasonable. And it's also keep in mind that you're encouraged to always profile things starting from MATLAB, and then as you generate the plugin, just bring it in, and you can use the plugin just as you can use a BST plugin or an AU plugin in MATLAB just as an audio plugin. It will be an object once you import it, and so you can profile it and tick-tock it just as you would do with a bit of a MATLAB code.
Okay, thanks. Actually, one more question on performance, whether we can expect like vectorization-based speed to translate to a C++ code. I assume that, this is a question from Max, I assume that they mean stuff like SIMD and kind of vectorization, which
right. Yeah, good question. SIMD is a good example of sometimes it's not about vectorization itself. Vectorization itself will be translated, but vectorization itself is important specifically in MATLAB because it means calling a function interface only once and crunching number for the rest of the time. In C++, everything is flattened out. So the impact that vectorization has is not as important as it has in MATLAB. But it's best to use the code that you expect to be efficient in MATLAB. Now, you won't get SIMD indeed in the generated code. And that's where things don't allow you to, at present at least, to step in very easily in plugins and swap things that you expect to have optimized outcome. So expect that you would get a reasonably efficient serial C++ in the code, in the plugin that gets generated by MATLAB.
All right, thanks. There's also, because you talked about Juice, there's a question whether Juice is actually used by MATLAB directly when generating plugins. And what I understood is that you actually generate a producer project, right? So you get like a full kind of Juice project, which you can either compile then, or maybe even copy paste parts of it somewhere else.
It's correct. I mean, you can get. I imagine that always as a more advanced workflow because it's for more people that know more. But let's start from that. You can generate a producer project that you can just drag and drop in producer and export, say, to Visual Studio, whatever that is, or as code and compile it. Okay, and that's open. It's all source code. But you can also avoid doing that and just use Juice under the hood. So MATLAB ships with a core of Juice. It's not a distribution of Juice for you to use. It's you shouldn't go there and find it, but MATLAB can do the whole thing. So it can create the project and compile it, and that's the easiest thing to do. And you don't have to worry about it. It just happens. And yes, what it uses is a specific version of Juice.
All right. So maybe a couple more questions. So we have some about latency, because that's the other, apart from performance, that's the other kind of concern. So Full Kick Productions is asking whether there's a latency cost associated with the matrix processing versus the per sample processing. And then Max is wondering whether the latency is even actually reported at all, like, for example, to your DAW.
Great. So there's three different aspects, I think, about this. The first is the latency associated with passing audio in and out of sound interfaces. And that really depends on, so if you are in MATLAB and you're doing real-time audio processing in MATLAB, as you've seen, that really depends on the number of samples per frame that you use. That is the variable that establishes your latency. There's no specific latency going through the plugin except from the latency that is associated to choosing a specific block audio length of block of audio. So that's really what makes your system have a latency. And so if you imagine passing a block of audio or using whatever plugin with 32, 64, 128, 256 samples per block, that's the latency you incur. You don't incur any extra latency cost by coding a plugin with MATLAB, except if you do something inside your plugin, for example, using a ping pong buffer or anything like that, or using frequency domain convolution. That depends on what algorithm you choose. Yeah, in that case, you definitely incur some algorithmic latency. Then there's the last aspect, which is reporting the nominal latency. That thing that plugins can do has nothing to do with what they actually do. It's what they think they're doing. And you can hope that if that was developed by somebody that does the right thing, that's the same thing that's happening. So right now, plugins already from MATLAB have no way of reporting that value to the DAW. We're working on it. So just stay tuned. That may well come out. I don't have any clearance to talk about future release. That's just the way we work. But
I get it. Like, I had been developing plugins for a while, and like I've seen that if it gets sufficiently complex and you have like complicated stuff going on, then figuring out the latency dynamically and reporting it correctly to the DAW actually can become really, really non-trivial and quite complicated tasks. So
you're right. And when we heard about that, let me say that we come out with new stuff every 6 months. Our releases have the end of the year. Like this year, we had 2020A, which is the spring release, and then it will be a 2020B, the autumn release. So stay tuned. As soon as the pre-release comes out, you can try it out. You can download it and see what's new.
Last question maybe for you from Max, whether you can say anything about the use of deep learning models in the audio plugin toolbox.
Yes, so that's a very good question. So things are not completely straightforward. MATLAB's got a ton of stuff these days new that came out new for deep learning. And yet things are not yet straightforward in that you use a network as you would use it normally in MATLAB and generate code. However, there's some tools that we haven't been able to ship, but we can make available that take a deep learning network developed in MATLAB and generate the very MATLAB code that implements that network. And that is completely compatible with C code generation. That's the kind of things that Christian used in his project. Christy, he must have talked about that a couple of sessions ago. And so he did use a convolutional encoder. He coded it up in MATLAB. He coded it up by hand to start with. But what he could have done is import kind of a Keras or TensorFlow network into MATLAB, then run that function that I can possibly make available if you get in touch with me, generate the whole MATLAB code for the network, and then turn it into C++. Again, no optimized library, so be mindful of what you're doing. If you've got a very large CNN with tons of layer, right now, today, that won't be super efficient using this approach.
We actually have one more question from Spencer here in the group, pardon me, who asks, are there any resources for writing real-time safe code with MATLAB?
Well, real-time safe is a good concept. I think it's especially interesting when you have control as an author. You have an API that allows you to play with multi-threading. MATLAB uses a ton of multi-threading, but it's all encapsulated from the user. So there's a lot of data parallelism and optimized libraries, but you don't get to create threads in MATLAB. And so real-time safe, I wouldn't have called it that way. But yes, this documentation in terms of, for example, how to structure code for real time and how to optimize. So in terms from a performance perspective, it does do the best that it can in real time.
I just figured out that if we have like questions to each other on the Zoom call, then we can actually unmute the mic and just ask them, right?
That's right.
I just it didn't occur to me before. That's funny. Anyway, so yeah, thanks a lot again, Gabriele. That was really, really interesting. Yeah, we come to our next speaker, who also works at a very famous music tech company, very well known, namely Ableton. Hello, Spencer Rudnick. Spencer transitioned from web development to music software development at Ableton, learned C++, learned DSP, contributed to open source web audio tools. Hi, Spencer.
Hey, thanks for having me. And just as a quick introduction, I've been working at Ableton for about a year. I started in web development, as Timur said, and I also use they, them pronouns. So just to get that out of the way.
Great. Yeah, thanks so much for your time, Spencer. And this was a conversation that Spencer and I had about a month ago, because one of the most common questions that I see in the community is people ask me how to get an audio programming job. And I thought Spencer had a very interesting story, because while I was doing ADC last year, I had heard, I can't remember how, I think Spencer may have told me that they had actually got a job at Ableton. Well, we were having a conversation after ADC where you had said that you were working on the live team and that you were trying to learn C++, and you were working on that, and that really caught my ear, because working on the live team, of course, you're working on Ableton itself, and that I thought, learning C++, but working on the live team, how's that working? And so I thought that we would have this conversation just to discuss in a more global manner how a person can get an audio programming job, and specifically maybe how you got your job. So can you tell me just a little bit about your development journey, just how you got involved, where are you coming from? So you're from the States, correct?
Yeah, I'm from Chicago, or just outside Chicago. And I actually started thinking about audio programming the first time I ever played with GarageBand. I thought, this is amazing, like the ability to like use these computers and express yourself and do all sorts of weird stuff that the people who made the software never intended. Like enabling people to have this kind of experience is something that I always really wanted to do. I went to school for computer science, but never really did anything with audio programming until I had to learn React for a job.
Yeah.
And I learned React by building a web-based synthesizer. And this was like, I guess, my introduction to audio programming, and kind of kickstarted everything to where I am now. So yeah.
Amazing. And so what year was this when you were writing this web app with React?
This was about 2 years ago.
Okay.
I started making it, and yeah, that summer I started following a lot of people on Twitter in the web audio community. I got more involved in the web audio Slack, and just learning more and more about it. And along the way, I'd found that Ableton had some web audio projects, the Learning Music project, and since they've released the Learning Synths project, and this, I guess, caught my attention, and I started following more people at Ableton, and eventually saw that one of their managers was tweeting about a job opening, and I just reached out and said, I don't have C++ experience, but I'm going to apply anyway.
Yeah. And so was the job description for a C++ developer?
Yeah, I looked for some experience with C++.
Wow. And so how did that conversation go? What was your first contact with the HR office? What did you say?
Well, I made it clear that I really wanted to work there, and that I don't know C++, but I'm willing to learn it, since it is required there. When I had to, they send you a test, and when I worked on the test, I taught myself C++ for a few days. I actually didn't know how to change the standard version, so I was using C++ 98 the whole time and had no clue about how to get any of these newer features.
Wow.
So that was kind of a pain. And
Wow.
yeah, looking back, I could have done a bit more research before I just dove into the code. And but yeah, that's
So when you did this test, did they give you feedback afterwards on how you did, and what were their thoughts?
I think the conclusion was that it was clear I was not an audio developer. I was not a C++ developer. They could tell that from the code.
Mhm.
But I think what was interesting was that the way that it was structured anyway was it showed thought and like care over what the abstractions were and this kind of thing.
Wow. So it was even more about just the technical coding itself. It was more about the thought process behind the coding.
Yeah, exactly.
Yeah. So I heard a couple elements that were really interesting to me before this current thread. So you were saying that during the time that you were starting to develop this web app, that you started getting involved more with the community, and you started following people that were working at Ableton. Do you feel that that was a critical part, or that was a factor in being able to find this opportunity?
100%. I mean, I wouldn't have known that the job existed if it weren't for Twitter. So,
Yeah.
and also I think being part of the web audio Slack, I learned a lot about how active the audio programming community is in Europe. And I was living in Chicago at the time, but I had thought about it at some points in time, and learning that there was such a community in Europe, lots of people really deeply involved in this and companies to work for. I started to think more seriously about moving. Yeah.
Very interesting. And what other factors do you feel were in play there when you were actually applying for this job? So they saw that you were able to abstract the thinking and your method for problem solving. And what do you feel were some of the other critical elements that were in there that helped kind of push you into the next set of candidates, or helped you get the job? What are some essential ingredients that you would say helped you get your foot in the door?
It's a good question. I don't really know too much about, other than what they've told me along the way. Mainly, which was about like the technical solution. I think part of what's really important there is just to be honest about yourself and try to be open about what your goals are and what to pretty much state clearly what it is that you'd hope to be doing. And I think I guess what I told them was that, like, they asked me what I think it was like, what would you do if you could do anything? And I said, make music software.
Yeah. Amazing. Yeah. So it's the ambition and and also the capacity to pick things up quickly. That sounds like it's important. And, and that's one thing that I noticed when I contracted at Ableton, was going into the building, and of course meeting you and meeting the rest of so many other people from the team, was that how much the personality and just things outside of the technical ability to code seem to be very critical to the foundation of the way that Ableton works, and that there's a definite push to have a team that is more diverse in ways of thought, from diversity of background. I remember even going through the hallway, just running into Gerhard, and I didn't even know who he was at the time, and he stopped me in the hallway, and Gerhard is the CEO of Ableton, and he stopped me in the hallway and he said, "Josh, we really need to sit down and we need to have a talk." And I thought, and I said, "Oh, that sounds great. Well, who are you? I'm Gerhard. I'm the CEO of Ableton." I thought that was the most amazing experience. And even after, and even when we met for the meeting, the first thing that he said in the meeting was, "What can I do for you?" So what is it that I could do for you? And I thought, wow, that's just the most amazing thing. That really left an impact on me. for the CEO of a company like that to really take time out of their day to say, hey, how can I help you? And yeah, so going back to my point, it seems that that Ableton have found a way to transcend the kind of traditional way of, okay, let's see how good of a developer you are, how quickly you can code through this problem, and that it's transcended into a way that they can develop talent. And can you tell me a little bit about, once you got into Ableton, so you're here, you've inducted into the live team, how does the team then take and start cultivating your growth, and how do they introduce you into the team in a way that you're able to actually work and make a contribution?
Yeah. So I guess one thing would be that they made it really clear that they don't expect a really steep learning curve. They want you to like take the time and deeply understand what you're dealing with. Of course, I mean, like you want to feel productive, and like nobody wants to be doing nothing and making 0 pull requests for 6 months. So like they do a really nice job of saying, well, here's a bug, here's something that you can work on alone or ask to pair with somebody. I think pair programming is a really big part of what's going on there.
Yeah. Can you tell people about? I'm sorry to interrupt. Can you tell people just that may not know what pair programming is? Can you let them know what that is?
Yeah, it's when people take turns at the keyboard. It's called like taking turns driving, and it's a chance for people to kind of express code how they want to do it. You know, you can, if you're watching someone code and it gives you know, you can't control what's happening, it gives you a different perspective. Whereas once you get your hands on the keyboard, you can try something out. And it's this kind of duality of watching someone else who knows what they're doing and having the chance to ask questions and say, well, what does this operator do? I've never seen this. Or like, what are these variables that we're talking about here? And then the chance to actually apply what you're learning right away. And I think it's a really fundamentally important way to learn about a piece of software that you're working on, especially when it's 20 years old or something.
Yeah, that's amazing. And can you tell us a little bit about kind of your growth? So how long have you been at Ableton again?
Yeah, so I started in May of last year.
May of last year. Okay, so you're running on about a year now.
Yeah.
And so can you tell us about a little bit about your growth? So just starting out and then now, where, as much as you can say, of course, what sort of, because I think that a lot of people that are outside of the industry may not be aware, but there are different types of C++ developers at companies, aren't there? And you have people that work on the engine and people that work more on the UI, front-facing things. So where are you mainly working on now at the moment?
Yeah, I'd say most of my work is in the UI. I'm on the live team. There are other teams like that work on the devices and the DSP, whereas the live team is more about the user interface of the application, the infrastructure, the data and everything kind of on the metal that's happening other than DSP. So mainly I'm working in this area. I have done a little bit of work in the engine, but nothing like beyond scratching around and yeah. But so I would say like it's been really helpful also at work to have a mentor. So I did have a mentor pretty early on, and we worked for about 6 months together. We read the standard, which was, I think like kind of a brutal way to learn C++, but you know, if you want to know how C++ works, like the definition of the language is a good place to look at. There was also a lot of time spent doing exercises to learn about memory management and different kinds of standard library algorithms and types.
Yeah. And so I'll pose a question to you that a lot of people pose to me, which is, do you have a recommendation in terms of the best way for people to learn C++ if they're starting from scratch, or if it's it's their first language? There's a common maybe argument or different ways of thought. Some people think that, oh, I need to grab a textbook from Bjorn Strostrup, or other people think, oh, I need to build something and do a whole bunch of projects and put them on GitHub. So where do you stand in that sort of spectrum?
Yeah, I mean, I think it's a mix. I think early on it's really useful to maybe watch some tutorials, watch some talks about memory management and learning about like the memory model in C++. I think this is super important to understand. But when it comes to just the language syntax and all this stuff, there's a lot you can learn just by looking at open source code and like researching something you don't understand.
Mm-hmm. Mm-hmm. And outside of the technical skills, what sort of things do you think? Because you work with a team, how many are on your team? About
my team personally, we've got a designer, and then we have 5 developers.
Yeah, and can you talk a little bit about the things outside of the technical aspect of coding, outside the actual coding? I think that people may underestimate how important these other things are. Can you talk a little bit about the soft skills that a person needs to be an audio developer?
Yeah, sure. I think like one of the main things is like empathy with the user. It's super helpful if you yourself are someone who's interested in using this thing or using what you're making. But also, I think being open to the experiences of other people is really important. Another one I think is like nonviolent communication within your team, because a lot of the times with things like music and with like something that might look a certain way, there's a lot of emotions involved, and making sure that everybody is feeling safe and comfortable to express how they're feeling about some decision is super important. I think on any team, but especially one where people have their own interests built in, sort of.
Yeah, absolutely. And that brings up a great point, which is talking about code feedback and code review. And I know that this is something that is very important at Ableton and at a lot of companies in terms of being able to give feedback constructively without necessarily being abusive, which kind of touches on what you were saying. Can you offer some advice to people in terms of what are some things that we can keep in mind as an audio development community for being able to feedback when a person is maybe not doing taking the most effective approach when they're coding? What are some ways that we could that you think we could do that, or how do you practice that in terms of the way that you do it at Ableton?
Yeah, I mean, so with my experience level with C++ and my experience level in the live code base, I would say most of the time I'm doing code review, I'm asking questions about something that I don't understand. And I think like if you are a senior developer and you have junior developers on the team who are less experienced with the code base, I think this is a super useful thing to cultivate. And it's something where like I didn't do it on my own. It was like I saw the other people on my team doing this. Even like very senior people would ask each other, what's this, what's that, like not being afraid to look stupid or something. It kind of creates this culture of teaching that is really useful. So I'd say like I don't necessarily have any advice other than to like be open to questions. And but that's from my own perspective and what I've found to be a really good experience from people giving code review.
Yeah. That's great. Trying to think if there's anything else. Is there anything else that you feel we should touch on that we haven't yet?
No, I would just say something like, if you are interested in it and you know a language that can do it, that can do audio programming, you should try it, and not worry about doing it in the right framework or the right language.
Yeah.
I think
That's
into audio programming, where I already knew JavaScript. The web audio path was like a really low barrier and a really fun way to get into it. Learn about like declarative audio programming and custom DSP code, and without having to worry too much about some kind of framework or something I wasn't already familiar with.
That's right. And another thing that I see in this same vein is that I see a lot of people worrying about doing things the right way, the most optimized way, the very first time around. And the fact of the matter is that you're not going to, because it's just impossible, because there are too many. I think that as you get to be a more experienced developer, that you start thinking of multiple angles on your design decisions at once, and that it's impossible to do that when you're unaware of the forest for the trees, and the opposite. So the biggest thing is to get started, just to start. And as Spencer said, don't worry so much about the language, the framework, these things that people really spend a lot of time on. And just get in there and get coding and get learning, and that's a great way. Otherwise, you just stay stuck in place and not doing any coding, which isn't doing anything for anybody. Great. Well, I think we can end things there. Well, thank you very much for your time, Spencer. Are we going to open this up to questions from the community? Do we have anything?
Yeah, we have a couple of questions.
Great.
Some of them actually are around recruiting at Ableton, so I'm not sure how much you want to go into this, but like, so SOM asks, does Ableton take interns?
In some cases, yeah, we do take interns. Another thing we do a lot of is like work study. So if you're in the university and you're studying something relevant, they'll have students come work for a little while. So it does happen, but it's more often that they're looking to hire someone, I think.
All right. And then Akash asks, they are a data scientist and they feel that analyzing real-time software data is important, and whether Ableton is doing stuff like that and looking for roles like that.
Analyzing software data.
Analyzing real-time software data, kind of.
I guess I'm not sure I understand the question. Is it about like software usage data, or is it?
Well, I guess it would be whether you use kind of data science methods and apply them to audio software. I think that's how I interpret the question.
I see. I mean, I think it is important, and there's like actually a lot of really interesting ways that's opening up right now, like with music analysis and this kind of thing. I wouldn't necessarily know. I don't know that we're doing much about this yet.
Yeah. Data analysis, really, the first thing that really makes me think of is machine learning. That's one of the first things that come to mind with me. I don't know.
Yeah, I've heard some interesting things about this, but no, I don't know that we have any openings about this right now.
Right.
But I guess people can always go to the Ableton website and see what job openings you have, and then also probably get in touch if they think they would fit in, but their description is not on there, or nothing that fits. I guess they can just get in touch, right?
Yeah, there is an open application, I believe. So even if you don't see something, if you want to send your information, you think maybe I have this skill set that would be useful, I think they do accept people's applications.
Right, because there's quite a few more questions around where would I fit in at Ableton and things like that.
Okay.
Just, refer them to that.
Sure.
Another question, though, is, so that's about the current situation with coronavirus and everything, whether you think that has impacted the audio programming industry.
I mean, since it happened, I've talked to a few people outside of this. Like, I was just actually talking to Josh about this. I've talked to a couple of people who are interested in transitioning from something else into audio technology. And I don't know if it's exactly like coronavirus had an impact, or if it's something about just how people evaluate their life when a big change happens. So I would say maybe there's more of an interest in it. And I think in a lot of ways, with having to be distant, maybe we need to think about how we can still be together. I think we're doing that right now, but there's lots of other ways that it can happen, maybe in a musical context.
The way I interpreted that question was something more like, has the virus itself really changed the way that Ableton as a company has had to work? Have you had to make a very big change in your workflow, or was it pretty seamless?
We're like an in-office company for the most part. There are a few people who work remotely, but by and large, before this, we were an in-office company. Now we are all working from home. Those of us who have Wi-Fi are doing so. So I think with the regulations in Germany, we might be starting to go back to the office in the near future, but I can't say for sure.
Would you say that it was a big adjustment needing to go out of the office? Okay.
Yeah, there was quite a large adjustment period, I think, initially, where people were really just trying to figure out how they can continue to work together.
Yeah.
But I don't think we're so unique in that way, especially for a company that was already very tied to an office setting.
Yeah. Going back very briefly, because I have a little something to say for people that are looking at applying to a company like Ableton, or for that matter, any music technology company, and thinking, and what I would say is, I think the conclusion that I've found in my short experience, maybe 2 years, is that there are different ways to get into companies. Some people just have the raw experience and the raw skill as a software developer to get in. Other people, they have different ways of thinking about problems, and different ways of approaching the situation, and they understand things from a user experience, and that brings a lot of validity into a software a music software company as well. And then more than anything, I would say the ambition to learn, to show that you're very into what's happening, that you have the capacity to pick things up quickly. More than anything is what I've seen in my experience that will actually get your foot in the door with one of these companies. Because when it comes, one thing that I'll tell you as a person that has worked with a lot of different companies is that there are a lot of people that can code, but there aren't a lot of people that seem to have the entire package, and entire package meaning the ability to work with people, and to play nicely with people, and the ability to think of things from a user experience and not just from a software development standpoint. So there are a number of different ingredients, and not all of them are just the technical how to code. So that's something that if you're looking at applying at one of these companies, that's something that I would really just encourage you to think a lot about. Think about the people that are using the thing that you're trying to build, and things like that. So great.
Yeah. That's also very consistent with what I experienced in my career. Like sometimes you do have a very specific, very hard problem where you need like a very specific piece of knowledge, but it's, I found not to be as important as many people think. And, some people have this rock star developer kind of thing, and we're looking for rock star developers. I actually heard this from companies, and I just really don't agree with that, because my own experience working with teams is that what really matters a lot more is that people are really passionate about what they do, that people work well within a team and have each other's backs. and that kind of stuff. And I just found that that also leads to the team being more productive and more awesome products being created. And I've seen this consistently, you know, so
Yeah.
I also very much agree with that. If we have time for one more question, there is one from Michael Kaufmann who's asking about the interview process. So if you're being interviewed, for example, for a junior entry kind of software development role, can you give me an example of like a problem that you would be asked to solve, like an audio related one and more like a problem solving one?
Yeah, I don't think I can give away what the problems are, but I think with a quick Google search, you might find the results.
Okay. I think it's not even a question about like specifically what Ableton is offering when you apply there, but more like the kinds of problems you would encounter, or maybe how you would, whether you would have to like prepare for this specially, or you know, any kind of advice you would give to someone who wants to prepare for an interview like that as a junior developer.
Yeah, I can't speak so generally, but I guess I could say abstractly that like we give away like the problem is to make like a console application. So you should be familiar with standard in and standard out, and understand the kind of Unix style of console application. But other than that, I think it's really just a question of like they give you a problem that is about like maybe it's somehow related to the software they make conceptually, and when you basically what they're looking for is not necessarily to do the right answer, but to write expressive code that shows your thought process, and you know, you can always choose a different data structure, you can always choose a different algorithm, but it's sort of like the why that needs to be clearer. If that makes sense. I hope that answers the question. Realize I've been bad at asking or answering questions today.
No, I think that answers it really well.
Yeah. I think that makes a lot of sense. Thanks, Spencer. Thank you again very much for taking your time and talking a lot about your experience. I think that's very valuable for many people, and very interesting and inspiring as well. So thank you very much for that.
Before I was going to say, before we go into our final talk, I thought that it might be useful if everybody here just lets everybody know their Twitter handle, just for people to follow and keep up with each other on Twitter. So mine's pretty easy, of course. It's actually not the Audio Programmer; it's Audio Programmer. That's on Twitter, and Teamer's is Teamer_audio, correct?
Yeah, it's Timur, just my first name, TIMUR_audio.
Yeah, and Gabriele, are you actually on Twitter?
I'm not on Twitter.
Yeah,
I'm still part of the old generation, and I can't get my head to stick in there. You can find me on LinkedIn.
Yeah.
Little that I do it over there.
Yeah. So follow Mathworks at Mathworks. And Scott.
Yeah. So there was already Scott Hawley. So I'm Dr. Scott Hawley, Dr. Scott Hawley, all one word on Twitter.
That's it. Doctor, you earned it. And Spencer? Oh, your mic's muted.
Sorry. Yep, I just pasted it into the chat because it's hard to pronounce. It's Shorokit.
Great. Yeah, that's SHORO_KIT. Yeah. So don't beg him for Ableton jobs. But great. Well, that's fantastic. So Teamer, shall we jump into the last talk?
Yeah, I think we're ready for the last talk. I'm really excited about that. So we have Scott Hawley, who is a professor at Belmont University, he's teaching physics there, physics classes to audio engineering majors. He's active in the Audio Engineering Society and the Acoustical Society of America. And Scott is contributing there to projects that combine ML, acoustics, and signal processing. So that sounds really, really interesting. Thanks, Scott, for joining us tonight. And your talk tonight is called Vibrary, Train Your Own AI Audio Classifier. And that sounds really, really interesting. So let's jump into that. Hello, Scott.
Hey, everybody. Timur and Josh, great to be here. Really enjoyed what y'all have been doing for a while. And I say go ahead and play the pre-recorded talk, and then I'll be happy to add some more stuff at the end. So it's about a 20-minute video I made.
Great. Here we go.
Hi, I'm Scott Hawley. I'm going to be talking about Vibrary, train your own AI audio classifier. And this is work done with Jason Bagley, who's the main programmer on this, along with Brett Porter and Daisy Trainham. And Jason, Brett, and Daisy are all at ArtLogic. The GitHub repository for this project is here, and you'll see that posted repeatedly throughout the talk. So the basic idea is that producers and composers often have very large libraries of audio samples and clips, and usually these have some kind of metadata tags to tell you what the clip is about, but they don't always agree. And so sometimes it could be a challenge to find what you want. And so one idea is to allow people to train their own machine learning system to tell it what sorts of things they're looking for. Train your own. We really do mean the end user. So a lot of machine learning systems these days are trained by a company and then deployed to the end user, and the end user can only use the trained model, but they can't train it themselves. As far as audio tagging goes, or audio classification, National Instruments has their sounds.com. There's some apps called EXO, Atlas, Samply, and probably others to help you find samples on your hard drive. But as far as we know, none of them allow the end user to train their own model. And so we're about trying to democratize AI and machine learning by putting training in the hands of the end users. But end users tend to lack the computational resources, which usually involves graphics processing units. Tools that are trainable may only be accessible through a Unix command line. There's not some nice user-friendly way of doing it. Also, it's the case that end users are not data scientists, and that can actually affect the results you get. We'll say more about that later. The basic idea with Vibrary is we combine the GPU server to get computation to people who may not have the hardware with a user-friendly GUI client on the front end. So a quick summary of the project is there's nothing new under the hood. This idea of using convolutional neural networks on spectrograms, and specifically MEL spectrograms, has been around for quite a while, and our model is actually rather simplistic. But the package of putting it together in a way that makes it easy for end users without specialized hardware or expertise to be able to do this, that's the main effort here. Our method is fast and accurate. We find that it tends to be more a function of the user's choice when they make their own data set than it is about the particular neural network model system that we're using. A little bit of the timeline on this. I have a club in Nashville called Aspire, which is people who are into audio or acoustics research and development, kind of getting together to pool our efforts or share what we're working on. And in the context of this, I was having coffee with Ethan Henley, who is a producer, and he expressed this issue of, gosh, I've got so many audio samples. How am I going to find what I want? And I said, well, actually, I have a audio classifier. It's one of the first projects that I did when I was first learning about machine learning. My system, I called it Penati, just based off these supposedly ancient people that had really big ears that could hear really well. And so throughout this talk, you're going to hear me talk about client and server. The client is the Vibrary GUI. The server is the neural network classifier training system, which by default is Penati, although you could replace it with something else. So really, Vibrary ends up being kind of a sweet front end for Penati. It wasn't really going to turn into a real product. That was just too much effort. But right at that time, ArtLogic announced a contest where they said, send in your idea for a audio-related app, and we'll pick one and turn it into a real thing. And so I submitted my prototype, which back then wasn't called Vibrary, it was called Sorting Hat. And the HAT stood for Hosted Audio Tagger. And the prototype was built through a hackathon. And so that got picked by ArtLogic. So we've been working together for a few years now. Okay, so here it is. This is Vibrary. I'll show you a demo in a minute. And so the client server system, the client is the GUI. It's built in Juice with C++. And the server, which gets connected to just over SSH. We don't have any special API yet. You could write one if you want. right? So we just SSH the data back and forth. Now, ideally, the server would be, say, up on Amazon, and it would spin up when you need it and spin back down. We haven't gotten to that part yet. So right now it is supply your own server, essentially any computer that allows SSH access where you can install Python and Keras and TensorFlow and stuff. And as long as you can SSH in there, then you're done. And there are instructions on doing this. Jason has written up a lot of great instructions on the GitHub site. So I'll say more about that later. A little bit of background on the method, right? Audio classification, it's a subset of music information retrieval, which is a really, really big field. People have devoted their lives to it. I am not an expert in that area. This was just a project I wanted to try, but usually you extract features from the audio in various ways. You might use it for a recommendation system like Pandora. One way of doing this is by turning the audio into an image by making a spectrogram and then use image classification methods. This has been done for quite a while. I noticed it. Kyung-Wee Choi, who's at Spotify now, he won the best paper at the Music Information Retrieval Society a couple years ago, and I kind of dumbed down what his work was so I could make it work. All right, so one idea is don't actually upload the audio to the server in the cloud. Instead, generate the spectrograms locally using the user's CPU and then upload them and train on the cloud. So the basic workflow goes, you, the user, build the data set, the client will generate the spectrograms, it'll upload those spectrograms, train the neural network, and then you'll download a copy of the neural network. You'll download the weights that make up the neural network. And then the Vibrary client will execute a copy of that neural network in what we call inference mode. Nice things about doing this, the spectrograms are a lot smaller than the audio itself. The original prototype, we were uploading raw audio, and that just takes way too long. Also, if you upload raw audio, then you could get in trouble for licensing, for redistributing, say, copyrighted material. So if you're only uploading the spectrograms, then there's a huge data reduction, and you're not going to reconstruct the full quality audio from the spectrograms. And then one other thing about this approach is that by using the MEL spectrograms, we're taking advantage of some domain knowledge of audio. We're not just training a raw waveform domain neural network model like, say, WaveNet. And that actually allows us to perform pretty good on relatively small data sets, small meaning like tens to hundreds of examples, as opposed to like tens of thousands or millions. In order to get this thing working, we try to keep it simple as far as what we imagined producers and composers would want. It is open source, so if it doesn't have features listed that you want, you can add them. One thing is that it's modular, so you can keep the client, swap out the server network. One simplification is that for each set of neural network weights, which we call a sort file, we only associate one tag or one category per audio clip. You can do multiple different sort files, but you're only going to get one tag per sort file per audio clip. That's just to keep it simple, right? It also doesn't do hierarchies, but we allow for multiple different sort files. So you could say have a sort file for genres and another one for instruments or whatever, and you could run them in succession. And people could share their sort files with one another. You know, there are companies that will sell famous producers presets to, say, a mastering plugin or something like that. So you could imagine people sharing their own individual sort files that they've worked on. We don't have an infrastructure for that, but Dropbox or Google Drive, that would work. Also, we're not going to hang on to people's spectrograms. We could, but also defaults, we just stick to mono, sound clips of 3 seconds and 44.1 kilohertz. The idea is what's likely to work for most people. These defaults can be changed. And then people may want to know, well, how many audio examples should I supply for training? And the answer is, well, it depends. So I did some tests. My friend Kyle is a composer, Kyle Baker, and he provided me with a data set of 9 different instruments that he had. There's a rather well-known genre database called GTZan, and Fraunhofer IDMT has a data set of guitar effects. What I did was I plotted sort of the accuracy of the model versus how many examples you supply per class. And what you see is, right, the more examples, the more accurate it is. Some of this is a bit artificial in that there are 9 instruments, 10 genres, 12 effects. So it's not necessarily that effects are necessarily harder than instruments, but that's an example. A different neural network model might have different properties. For example, like a one-shot learning model, you could install one of those and see how that works out. But the training is fast, okay? So somewhere on the order of tens of seconds to, say, less than a couple minutes, even for relatively large data sets. It just goes pretty fast. I'll now show you a demo of Vibrary. So I'll go to github.com/artandlogic/Vibrary, go to releases, and I'll download the release. Just make sure I don't have it already. Yeah, I'll grab a new version. And so I've downloaded that, and we'll unzip it. And there's our app. So we'll run it, and we'll probably get an error from the OS because it doesn't know what it is. So then we can go to System Preferences, Security and Privacy, and press Open Anyway. And then let's double check on that. Okay, sometimes this happens with macOS Catalina, depending on how it was compiled. Yeah, I've noticed this with some other apps as well. Yeah, so another thing that we can do is go into Downloads, Vibrary.app, Contents, macOS, and just run it directly. There we go. And it's telling us that our Vibrary is empty, meaning that we haven't actually categorized any files. It says choose a sort file, and we've got a couple different sort files that have come with it. These are pre-trained neural network weights. If we press the space bar here, we can see one of them is pre-trained with brass and drums and percussive sounds and soundscapes. The other one is just trained on different parts of a drum set. So let's do that. I'm going to grab some audio from a different data set. This was not trained on. So yeah, so we'll grab some kicks and we'll see if it knows that they're kicks. So it generates spectrograms, and look, it knows they're kicks. Okay, and similarly, we can do some toms, and just in the interest of brevity, again, these are totally new files that this system wasn't trained on. What else can we do? Okay, cymbals and snares tend to be interesting because sometimes the snares or the cymbals can have some effects on them, and it's not uncommon for models to get them mixed up. Yeah, so occasionally, even though it says snare, it thinks it's a cymbal. So that's an example of inference, right, with different types of tags. Again, I can press spacebar there. Now, what about training? Oh, one other thing I might mention is that you don't have to do individual files. You could drag in entire directories. So for example, okay, I'm gonna have to speed this up in the video. I can drag an entire directory of symbols in here. This is gonna take a little while. So it's generating spectrograms for all of those. And you can see this little bar is getting shorter. It'd be nice if we parallelize this so it would go even faster. So I'm going to speed this up. Another thing we can do is we can listen to each of these. I'm not sure if my audio, you might not be hearing that, but you can hear it, or you can press the space bar. And from Vibrary, you can drag these files into different bits of DAW software as well. Oh, that's interesting. I've never tried that before. Okay, now if we choose a different sort file, then it doesn't have that. It says your Vibrary is empty for that particular sort file because we could have used a different categorization scheme. So what I'm going to do now is train a network. So it says create new sort file, and to connect to the server, so we need a username and a server. In my case, the server is called Hinton. And this is something that you need to have SSH access to and set up key exchange for this. So it's not going to get prompted for a password. And then we can go up here to our train. And it says create tags. So we're going to create some tags, and we can either type in a name or we can drag in a directory. So for example, I can drag in like this acoustic guitar stuff. And then I can drag in, say, some keyboards and sound effects. And I'll just do the other two here. Oops. Strings and voice. All right. And then when we're ready, we can say train your vibrary. And we'll say June 9 demo. And then it's going to generate spectrograms for all of those. And if you're running from the command line, you actually can see an entire log of everything that's going to happen. And we have a little status bar that's going. When it's finished generating all the spectrograms, it's going to upload them to the server. So now it's uploading. And it tries a few different SSH protocols first. And so once that's uploaded, then it's going to train the neural network. And this looks a lot nicer if you run it locally, but this is the training. And it'll be done. It's now done. And we're going to download the neural network weights. And it says we're done. Okay, that's for the old sort file. Here's June 9 demo. And so now we can take some other data and drag it in, see how we do. Okay, and it thinks they're mostly acoustic guitar, but some of them are getting classified as something else. Sometimes if you listen to these, yeah, it's not 100% accurate. I could have added some more examples. Let's try the keys. Oh, I didn't want to do that. Dragging the keys. And it thinks they're mostly keys, but some of them are sound effects. There may be some overlap as far as what's in the sound effect list. Sound effect is kind of a grab bag of a bunch of different things that I just pulled in from Apple Loops. Okay, thinks those are all sound effects. And for example, strings. So we can also, we can drag in individual groups of files. We can drag in individual files like that. So those are supposed to be strings, but it's thinking some of them are keys. And then we've got voice. Drag those in as well. And yeah. All right. So it seems to think a lot of those are strings. Interesting. That's not strings. Well, so work in progress. That's the basic idea. And so you can create your own sort file there. Demo for vibrary. If you want to train using your own server, you can come in here and change that information. And we've got information on the vibrary GitHub page for setting things up. Jason has written a lot of good documentation for if you want to build, if you want to set up the server. Got it over here. And I'm actually working on a version that's updated to TensorFlow 2.0. So hopefully that'll be ready very shortly. That's it for now. Thanks. So extending vibrary beyond what we imagined for it, as far as users, well, we really haven't had a chance to really put this thing through its paces as far as what it's good for and what it's not. There are lots of different studies in the MIR literature for people detecting things like beats per minute and keys of songs and things. We just haven't tried it, so we're really curious to see what people do with it. And certainly training models and sharing them with others would be neat. Tips for improving the user interface. Love to hear about that. As far as developers, so this is built in Juice. And so many of you are already familiar with Juice through Josh's teaching. There are all kinds of different improvements that could be made to the vibrary client. Some of the plugins I mentioned at the beginning of the talk have a really nice display where they sort of colored dots for the different categories. And yeah, we don't do that. It'd be nice to be able to do that. Also, file formats like Contact, we don't do those. Getting some help with unit testing would be great, right? And this thing only works for Mac. Also, I should mention ArtLogic. They hire audio developers from time to time, and everybody works remotely. It's a complete work remotely company. So just a little plug for them. As far as machine learning researchers, well, you could use Vibrary as a front end and then swap out the server model with your own. For example, Jordi Pons and over in Barcelona, there's this great thing called, it's pronounced Musician, and it's also based on TensorFlow. And so if you wanted to swap this out, I haven't really written out the full documentation for doing it, but the basic thing that happens is Vibrary is going to make a bunch of spectrograms. It's going to save NumPy, compressed NumPy versions of those files. It's going to send a gzip tar file of that to the server. And the idea is each folder in a directory is where all the classes are. That's a pretty standard way of organizing things. And then we train the model. That just involves executing some command via SSH. And then we download a protobuffer file from TensorFlow. And then Vibrary uses that. So if your machine learning model can simply take in a bunch of spectrograms, then do its training, then produce a protobuffer file that we can download and execute, that's all that really needs to happen. Now, one other thing that'd be great for some developer to try is maybe we don't even need the GPU server. Maybe if we do some data reduction on the front end with, say, principal component analysis, maybe people could do this on their CPU. It's not a maybe. We know people could. We just haven't gotten around to writing it. So summary of the project, letting users train their own models is, I think, one of the most exciting things about machine learning. And as far as I know, there's an app called Runway ML. It's great for visual art, and you can try out all kinds of different image processing algorithms that people have trained, and they allow GPU cloud credits. So for Vibrary, the underlying algorithm, it's not all that fancy, but what we're trying to do with it in terms of make it so ordinary people could use it, and not just producers or composers, but even, say, in my classes as a professor when I teach audio classes, this idea of classification is a neat thing that people are interested in, but it's not been accessible to them. So making it easier should be interesting. Once again, it's up on GitHub. You can mess with the source, swap things out, send us pull requests, send in issues, and we welcome any feedback. That's it. Thanks.
Right.
Yeah, thanks a lot, Scott.
Thank you so much, Scott. This was really, really quite impressive stuff. We have a few questions. First question is from Mathworks. Are there Docker images for the server?
Sorry, I got out of sync between the YouTube stream on my end is about a minute behind the live Zoom. So I'm trying to find our where did the Zoom thing go?
Yeah, it's tricky to find it sometimes.
It's somehow it moved. I can't see anybody anymore.
Can you hear us?
I can hear you, and I'm just going to assume everything is fine.
Yeah, we can hear you. Everything's fine. So
okay, good. So I'll just go purely on audio alone.
We're speaking to you from the future.
Here, so.
Right. There's like this tiny, tiny little window up in the. Oh my gosh. Anyway. There's a tiny Josh. Excellent. Sorry, Timur, can you repeat the question, please?
Question was whether there are Docker images for the server.
I think Jason answered that. The answer is not right now. That would be something that would be really nice. The server is essentially, so it's this package Panati. So, and you can download that and install that just with pip. You can clone the repo, and it's really just a pip install Panati and it'll do itself. So as long as you've got some computer somewhere that you can SSH into, the setup should be fairly simple.
All right. Then we have a question from Akash asking, what kind of resolution do we need to, what kind of resolution do we see for the spectrograms as images when it's sent from the client to the server? Yeah,
there's a default value that we set that seems to work pretty well. I mean, they're pretty small. I don't remember the exact dimensions, but it's something like 100 by 150 or 170 or so. If you change the duration, so we set a default of 3 seconds for each spectrogram. If you change that and make it longer, then you'll get larger spectrograms. And currently that's not in the binary that you download, that's not in settings. It's kind of hard-coded, but it'd be really simple to expose some of those things to allow users to make more changes as far as what the options are for spectrogram resolution and things like that.
All right. Then the next question is, how many classes can you have?
Right. Yeah. So, never tried a lot of classes. There's no hard coded limit in the code at all. I would say advisably. So I think the last fully connected layer on the neural network has 128 elements to it, and I wouldn't recommend trying to go above 128, but you could. There are models that do this that train on, for example, 1,000 classes, and for our use case, we just didn't anticipate people trying to do that. So in the interest of speed and storage and so forth, we made a choice to keep it kind of small on that end.
All right. So
Let me rephrase. There's no actual limit in the code anywhere. You can try whatever you want.
I think that clarifies it. Yeah.
Okay.
Thank you. There's another question from Akash who's asking, what's the average accuracy of the system, approximately based on the samples it's seen from now, which have been validated? And is there some way for the client to correct the tags?
Great question. Okay, so as I mentioned earlier, the accuracy depends a lot on you and the data set that you create. And so I'll just give you one example. A lot of sample libraries will have not just pure recordings, but they'll have kind of affected, noisy sorts of things. Like I've noticed a lot, there are things that get called a snare, where it's really this kind of noisy thing that might have a lot of sustained high frequency stuff. And that'll get classified as a symbol a lot of the times, because, and then you go back and listen to it and you're like, oh yeah, I could totally see why it thinks that's a symbol, because it's not a real snare, right? So some of these accuracy things are a bit subjective. But for example, all the data sets that I was using for things earlier today, it's not unusual to score, say, 90% accuracy on only, say, like 20 or 30 examples in a class. And you could set it to train for longer. So we also set a certain number of, we call it epochs or iterations as the machine learning model is training. And we set it for a default of 30, which, as you see, it goes through in less than a minute. If you wanted to train for longer, you could bump up the accuracy to a certain point, up to a limit. It depends on the data.
All right. So last question from Mathworks. Do you get a confidence rating for a tag?
Yeah, that would be a really nice thing for us to do. So far, we don't do that. And the information physically exists in the computer. It is essentially computed as part of the classification algorithm. We just kind of have thrown that information out once the classification is made. I'm not sure the best way to show that in the user interface. So it is possible. And if someone wanted to go in and modify the juice code to accommodate that, then that'd be great.
All right. So there's one more question just now from Toby. Mm-hmm. So Toby's asking whether you have experimented with synthesizing samples based on models like GAN.
Okay, that's a completely different application. So this is not a generative model. This is just a classifier model. So it only takes existing inputs. There are some really great work with generative adversarial networks and audio, in particular, like the Google Magenta group. They do some really great work with that. Mm-hmm. Chris Donahue is a guy who does some neat work with that. But yeah, that's not what this project is about.
Yeah.
All right. Yeah, thanks. Thanks again very much, Scott, for answering all these questions and for your wonderful presentation.
Mm-hmm. So, sure. Can I make one other comment since we're here? Since this is all about learning audio programming and so forth, and you have in my bio, I helped curate a web page of sort of advice for students, for people who are interested in getting into machine learning and audio, or deep learning and audio. And it's on GitHub, but it's a page that's full of like links to online courses and books and things like that. And so if one of us can post that into the chat, I can post that in the chat window in just a minute. And people who are interested in learning more about it can find some of those resources.
Yeah, I'll post it in the video description as well.
Cool.
So, and just one note on that. On that note, for a primer, if you've never done any sort of machine learning and you're looking to just get your feet wet with it. A great course to start off with would probably be Rebecca Fiebrink's course on Cadenze, which is a creative machine learning course, and it is fantastic. It's a course that I took while I was a student at Goldsmiths, and she's one of the authorities on this field. And that's a great one where she provides a very high level overview without getting too crazy into the math. And it's fantastic. I highly recommend it.
All right.
Cool. Thanks.
Okay, well then, I want to thank all three speakers again for joining us here tonight. It was really quite awesome. So thank you very much for taking the time to actually come here and, be here live with us. And thanks.
Yeah. Thanks again to all the speakers, Gabriele, Scott, and Spencer, for contributing their time. And thank you for tuning in. And also a big thanks to our sponsors, Focusrite, Juice, and Sonics, for helping to make this Audio Programmer Meetup possible. Join us on the second Tuesday of July. So we're doing this every second Tuesday, and the second Tuesday of July is on the fly. It is July 14th. So I don't have a flyer made up for it yet, but the date is July 14th, and we're looking for speakers for this meetup. If you would like to submit a talk, you can submit a talk on theaudioprogrammer.com/submit. And just a reminder for everybody, we're not looking for only people that have been in this business for 20 years. So even if you're a student and you have an interesting project that you've been working on that you feel that you'd like to tell people about, we would love to hear about it. Join us once again. I'll put the link in the chat as well. And in the video description, the link is theaudioprogrammer.com/submit, and the date is July 14th. So we hope to see you there. And I think that that's a good note to end things on. Does anybody else have anything that they would like to say before we sign off? Anybody? Anybody at all? Great. So I think we'll end things there. Thank you once again to everybody that tuned in. Oh yes, one other thing. For people that want to connect with each other in audio programming, be sure to join us in our Discord community. So we have over 3,000 audio developers from all around the world, all different types of backgrounds, all different skill levels. Come join us and ask questions and connect. So you can do that on theaudioprogrammer.com/community. So, and with that, we will sign off. And thank you, Teamer, for hosting, and thank you to everybody for joining in. And we will see you.
Josh, for running this thing.
Thank you.
Yes.
Thank
you, Josh.
Thank you very much.
Yeah.
And
All right.
Well, bye.
Well, bye everyone.
Guys.
thank you.